Hello and welcome everyone to my channel Code with Ease. In today's session, we are going to discuss about another sorting algorithm, selection sort algorithm. In the previous videos, we discussed about bubble sort algorithm and insertion sort algorithm. If you guys have not checked it out, I'm going to link it up in the description and also I'm going to link it up above. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So let's start with an overview of what selection sort is. Similar to bubble sort and insertion sort, this is also a very simple sorting algorithm. Again, not quite widely used for large data sets. It's suitable for smaller data sets only. Why? Because of the performance. The time complexity for selection sort is not quite good and it's not quite efficient for large data sets. That's why we use it for smaller data sets only. And it is in place because it doesn't require any extra space. Next up, we are going to see how this algorithm works. We are going to discuss about the central idea of this algorithm. Then we'll discuss the pseudocode for this and then we'll also do a dry run. Post that, we are going to discuss about the code implementation of selection sort algorithm. And at last, we are going to discuss the performance of this algorithm. So stay tuned. So now we will talk about how the selection sort algorithm works and then we'll do a dry run on this. So in every sorting algorithm that I have discussed as part of the sorting primer series that we are doing, in every algorithm I discuss about a central philosophy for every algorithm. So in case of selection sort, the central idea is pick the minimum or the smallest element in every iteration and put it at the beginning. Put at beginning. So it's a two-step process. First, pick the element, the smallest element in every iteration, and then put it at the beginning. This is the core idea of this algorithm. So now let's understand step by step how this algorithm works. So at the beginning, at every iteration, find the minimum element. This is the first step we have to do. How we will do, anyway, we will see that in the code. But I'm just writing an overview of this. First, find the minimum element and then end of the iteration. So in the first traversal, we'll find out the minimum element. At the end of the traversal, what we will do, we have to put this minimum element to the beginning. So we can use this a swap method, and where we are going to swap the minimum element that we have got with the whatever the beginning index is. So I'll just write swap the minimum element and the element at the beginning index. In that way, we are putting the minimum element that we have collected so far and pushing that to the beginning of the list. So that is all we have to do. So now we'll do a dry run on this array. So on the side, I have written the pseudo code for this. So first of all, we are going to have this outer for loop. So the outer for loop is going to run from 0 to n-1 and the inner for loop is going to run from j equal to I, and then this is also going to run till the end. At the beginning of the inner for loop, we are going to use this minimum variable, which is going to be initially equal to I, but later on we are going to manipulate the variable. So what we will do inside this for loop is the current element, whatever the ARR of j is, if that becomes lesser than the ARR of min, the initial value, whatever it is, then we are going to change this value to j. So in this way, inside this for loop, we are going to track whatever the minimum element is. We are going to collect the index of the minimum element inside this variable. And at the end of the inner for loop, we are going to call this swap method. So inside the swap method, we'll pass in the index of the minimum element that we got. And since we want to push it at the beginning of the list, I pointer is going to be at the beginning, so we are going to swap it with the ith element, the element which is the minimum elements index. So now let's get started on this. First we'll have these 2 pointers, so I and j. So the initial comparison happens and this is the min. So min will be equal to 0 first because I is equal to 0. So then j moves forward. So 2 and 5 is now being compared because min is 0. So 2 is smaller than 5. So this min becomes 1. So just write the index values also. Now min is 1. Now j moves forward. Now 7 and 2 is being compared. Now our min has changed to this element 2. Okay, earlier it was at the beginning of the inner loop it was 5. Now 7 and 2 is being compared. 7 is greater. So j moves forward. 9 and 2 is being compared. So 9 is also greater. Again j moves forward. Now 1 and 2 is being compared, but 1 is smaller than 2. Because 1 is smaller than 2, so this variable's value will change to 4, the index of the minimum element. This marks the end of the inner for loop. Now the swap method is going to be called. In the swap method, we are passing in 4, we are passing in i's value. So 5 and 1 is going to get swapped. So 5 will come over here and this will be 1 will be over here. So now we have 1, 2, 7, 9 and 5. So now I will start from here, j will also be here, and the variable this min will be reset. The variable min will be reset to the value of I, which is index 1. So then 2 and 2 is compared, nothing happens. Now j moves here. So now 2 and 7 is being compared, 7 is greater, same thing, nothing happens. 2 and 9, 9 is greater, j moves forward, 5 and 2. So at the end of this loop, technically no swap is needed because the value of min has been unchanged and the minimum value and the minimum element is at its correct position. So now I will move forward. Now j is over here. 7 and 7 is being compared, nothing happens, j moves forward. So now min will again reset. So min will be 2 because I is over here. 7 and 7 compared, then 7 and 9 is being compared, so 9 is greater, j moves forward. 5 and 7 will now be compared, so 5 is smaller than 7. So now the value of min will change to index 4. So at the end of this loop, now a swap will happen between 5 and 7. So 5 will come over here and 7 will be over here. So now the elements are 1, 2, 5, 9 and 7. So now I will start from here. So our min will be 3. So 9 and 9 compared, nothing happened. Now 7 and 9 compared, 7 is smaller than 9, so a swap needs to happen. So the value of min will again change to 4. So at the end of this loop, now 7 and 9 should be swapped. So 7 will be over here and 9 will be over here. So now again I moves forward. So I will be over here. Here again this is the last element and it is 9 is at its correct position also. So now finally the array is sorted. We have 1, 2, 5, 7 and 9. So now let's see the code implementation for this. So now let's start with the code changes for selection sort. So here I've taken this array and this is the method in which we have to write the logic for selection sort. I've pre-written this method I've pre-written the swap method already and we are going to reuse that. So let's get started. Since there's an in-place sorting algorithm, we have to change the array itself, hence the return type is void. So first of all, we'll have the outer for loop, which is going to run from 0 to the length of the array. Before we begin the inner for loop, we also need to take a variable to track the minimum index. And initially we are going to set this to the ith value. Now within this inner for loop, we have to do this check whether this is the minimum element, the current element is whether the minimum element or not. So we will check whether the ARR of j is lesser than ARR of min index. If it is, then we have to change the value of min index to the value of j. Now outside the inner for loop, as we discussed, once we have collected the minimum element in this iteration of the inner for loop, now we have to call this swap method with the minimum index that we have found and the element with which it needs to be swapped. So that is going to be the ith element because I is at the beginning of the list. So these are the two index positions that we pass, the I and the minimum index, and then the swap method is going to be called. Within this, we are simply swapping the values at both the indices. The minimum index value, the element at minimum index and the element at ith position. So that's all, that much is the code change. So let's try to run this. So here we have the sorted array. It starts with a negative integer and followed by the positive integers in the ascending order. Now let's move to understand the performance analysis of this algorithm. So now we are going to wrap up today's session by discussing on the performance of selection sort algorithm. So as it is quite evident regarding the time complexity, because there are two loops, so the time complexity is going to be exponential. If we talk of best case, when is that going to arise? When the array is already sorted. But even if the array is already sorted, we are still going to pick up the smallest element and try to put it at the beginning of the list. So the two for loops are anyway going to run. Similarly, now if we talk of the worst case scenario that is going to happen, let's say if the array is in descending order and we want to sort it in ascending order or vice versa. In that case also, both the loops are going to run. In average case, it is going to happen when the elements are in jumbled format. In that case also, the two loops are going to run in the similar manner. So irrespective of what the order of the elements is, the time complexity in all three cases are order of n square. Talking of the space complexity now, because the extra variables that we are taking are not dependent on the input size of the array, that is why the space complexity is going to be constant. So that's all about the performance of selection sort. Do let us know in the comments below if you guys have any questions or doubts or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.